Hello and welcome everyone. In this video, we are going to learn about how to write a program to check whether or not a particular number is a prime number, right? So what is a prime number? Let's understand that first. So a prime number is a number that has two factors. A factor means it should be perfectly divisible by that number and there shouldn't be any remainder. So for a number to be a prime number, it should be divisible by either it should be divisible by the number 1 and by the number itself. Okay, so that is what is prime number. So what we're going to do is the program that we're going to write, we are going to write a program where we will loop through all the numbers starting from 1 up until that number. So let's say if we say the number is 7, so we'll loop through 1, 2, 3, 4, 5, 6, 7. And then we are going to keep on dividing that number with those numbers. So first we'll divide 7 by 1, then 7 by 2, then 7 by 3, 7 by 4, 7 by 5, 7 by 6, and 7 by 7. Now, if it is divisible by any other number apart from 1 and itself, that means it's not a prime number. But if it is divisible only by itself and by number 1, that means it is a prime number. So in that loop, we are going to basically increment the counter value. So we'll create a counter and then we'll increment that counter value every time it is perfectly divisible, which means the remainder is 0. So let's try that. So first we'll do is say int, we'll say number, and then we'll also take counter. So counter, initially we'll set the value of counter as 0. Later on we'll check if the counter value is 2, which means it's got 2 factors, it is a prime number. Then we are going to take the number from the user. So we'll say printf enter your number, and then scanf %d for integer, and then and %, so it modifies its value num that we declared here. So we put that there. Okay. So we'll take the number from the user, then we'll run a loop. We'll say int I equals 1. So we'll start with dividing from 1. So that's why we're taking from 1 and not taking from 0. Okay. We are starting from 1. So we need to start from 1 and then up until that number. So how long we need to go run this loop? We need to run it up until that number itself, which is, let's say 7. Okay, so that number, whatever the user has entered. And then I++, and inside of this loop, we are going to check if whether or not that number modulus operator, because we need to check the remainder, by I. So each time we will divide by number. So first iteration, this becomes, let's say if that number is 7, 7 divided by 1. Second iteration, because we are doing I++, then the number becomes 2. So it'll be 7 divided by 2 and so on. So it'll keep on changing like so. So for instance, 7 modulus 1. So this will be equal to 0, and then 7 modulus 2, right? And whatever that remainder comes in. Okay, so I think this will be 2 3s are 6, so 1 will be the remainder, which means in the second iteration this condition will not be met, right? Okay, so anyways, you get the idea. So what's happening here? So we'll say count plus plus. So in case if the remainder is 0, which means it's perfectly divisible, then you will increment the count. And then finally, once that loop has finished, which means it has iterated from 1 to 7, for instance, then we are going to check if count equals 2, which means it was perfectly divisible by 1 and by the number itself. That's why the counter is 2, because it will only happen 2 times in that series. It wouldn't happen more than 2 times. If it happens more than 2 times, that means it's not a prime number. So if it happens only twice, it has 2 factors, which is it's perfectly divisible by 1 and 7. Then we'll just print I'm a bit lazy, so I'll just copy it from here. Okay. Okay. It's a prime number. And otherwise it's not a prime number. Let's try it out. So I'm gonna hit it. Let's see if we've not missed onto anything. Yep, I think this will be double equal to. I hope that's fine. Yep, here it is counter. What else? Yeah, this is counter. Yep, all good. So enter your number. We'll enter, let's say 7. Is it a prime number? Yes, it is a prime number, because when it loops through, it's going to divide that, and it is perfectly divisible by 1 and 7, but it's not divisible by anything else. We can run it one more time. Let's try something else. Let's try 8. It's not a prime number, okay, because it is divisible by other numbers. And if you want to see it, you can check it by the counter value, actually. So let me show you. So every time it's perfectly divisible, you can just echo out, sorry, you can just print out number %d. So every time it's perfectly divisible, it's going to print out. This is just for your reference, okay? So let's see what happens. So let's say I enter 8. Okay, let's put a new line. 8. There you go. So it was divisible, perfectly divisible by, okay, let me just put that there. Yeah. So this was perfectly divisible by 1. It was perfectly divisible by 2. So there was no remainder. 2 4s are 8, 4 2s are 8, so no remainder there as well, and 8 1s are 8, so no remainder there as well. That means the counter value would have been 1 2 3 4, and in which case it is not a prime number, because there are more number of factors. There are like 4 factors for this number, not 2. So it is divisible by either not only just by 1 and 8, but it's also divisible by 2 and 4, and that is why it is not a prime number. So I hope that helps you understand what's going on here, and that's how you basically write the program to check whether or not a number is a prime number. Okay, so I hope you did like the video. If you did, please give a thumbs up and do subscribe to my channel if you aren't already, and do share my video with others. Thank you very much. Bye bye.